Hello Sudarshan, good to meet you.
Hi Nasi, good to meet you as well. How are you?
Doing good, thank you. Sudarshan Krishnan is the CEO of Illumine Industries, a fast-growing startup that provides design engineering for many critical climate tech domains, solar photovoltaic, electric vehicles, green buildings. Thank you Sudarshan, thank you once again.
Absolutely, it's been a pleasure to be here. Hopefully we have a next good 20-25 minutes of discussion.
Yeah, so what I want to discuss with him today is design is a very critical component of every climate action vertical. And this is something that most of us don't see when we see a solar panel, when we see an electric car, when we see a wind turbine, when we see green buildings. What we don't realize is behind each of these, there is a lot of design that has gone in to make sure that each and every one of these solutions works precisely the way they're supposed to work and perform exactly the way they're expected to perform. So I'm happy once again to have Sudarshan, who is leading one of the prominent design engineering firms from India. It's a startup that's been in this field for now 8 years. They have been very successful in what they do. And what I want to talk to him today is more about the design aspect of what they do. So everything we are going to talk about is going to be around design. So Sudarshan, let me start off. As I mentioned, design is the invisible component in most of these. It's there in the background, but most of us don't see it. Well, it's true for any product, any conventional product. It could be a television, it could be a laptop, it could be a car. There is a feeling that design is even more important, even more critical for emerging sectors, which is what most of the climate tech sectors are, be it solar, be it wind, be it electric vehicles, be it green buildings. So design is far more critical for these sectors than others. Do you feel so? And if so, why?
No, that's a very valid point, actually. I can think of a bunch of examples. Let's say you're trying to put a power backup in your home, an inverter system in your home to have some kind of backup when the power goes off. In India, especially, that's pretty common right now. People are used to it. People have seen it, and no one is really worried about what happens if the system fails. Even if you take the legacy auto manufacturers, they also have quality issues on their product. The significant recalls that happens, which everyone knows it, but no one is really tensed about it. It just happens under the floor. Whereas recently, when one of the largest wind turbine companies were going through big issue of their wind turbines failing, it's still a big thing on the press. Where people talk about how wind energy is not so safe from a quality perspective. So for us, I took the example of the inverter backup that you have at your home. Any homeowner who wants to put solar on top of the roof is someone who is always going to be skeptical, because not everyone has done it in the past. If you take the US solar market, it's probably about less than 10% of homes that have solar right now. So there's still a significant amount of people out there who still haven't gone through the process of putting solar on the roof, right? So for us, we strongly believe in doing it right the first time, because we have come across a certain number of our clients, our homeowners, who have had their roofs leaking during rainfall, their electrical system getting short, having small fires due to improper design or engineering. So you wanted me to speak about design for climate, but I think I probably want to kind of coin it to say engineering for climate tech, because I think anyone can do a design, just about putting things on paper on a CAD platform. But I think for us, it's much more about understanding why a certain thing has to be done a certain way, and ensuring that compliance and diligence towards it. Because design is just design, but I think engineering is more design with diligence. We as a company strongly believe in having diligent engineering in what we do, and that kind of helps us stay on top of the industry trends, stay on top of code changes, stay on top of how market perceives solar right now.
So you call it design, you call it engineering. Essentially, it's far more critical for emerging sectors because the uncertainties are more.
Yes.
There are many more things that people don't know. There are many other areas in the value chain where things could fail that we are not aware about. As a result, design or engineering, as you call it, takes on an even higher amount of criticality. Is that what you're saying?
Exactly, and also the fact that legacy industries like automotive, televisions, people are used to seeing it, and recalls are not a big deal anymore. Recall for an auto manufacturer used to be a big deal about 10 years back, but it's not really a debatable topic at this point. So I think solar, especially solar and wind, are at a point where everything is going to be scrutinized. So it's important to be diligent in the first place. This is what we as a company focus on at this point.
That's true. That brings me also to another point. You see, unlike something like a television or a car, most of these, even though they are connected to an external ecosystem, to a very large extent, these are fairly independent items, to a very large extent. So which means the design for them also do not have to worry about what happens in the rest of the ecosystem. Whereas if you look at climate, if you look at power, if you look at energy, these are highly interconnected ecosystems where, for instance, if I have solar panels on my rooftop, I have to also look at engineering for the rest of the grid because this connects onto a grid, and this becomes even more important when I am putting up a large ground-mounted utility-scale solar power plant which feeds the grid. So which essentially means you are not designing for a silo, you are also designing to some extent for the ecosystem. Does that also play a big role, the way it's connected to the rest of the ecosystem, much higher connectivity to the rest of the ecosystem? Does that play a role in the way you design and engineer things?
That's a great question. I think I probably want to get technical a bit, but I try to stay not too technical because I think for the sake of audience who are listening to this, I think the ecosystem is not just about the grid. I think the ecosystem includes the equity partners, your developers, owner operators, manufacturers, OEMs, everyone. So I think you mentioned utility scale projects, right? I think over the last 3-4 years, there is the biggest trend that we have been seeing is the fact that all the assets are underperforming at least 2-3%, and especially those 100 megawatt sites. If you dig a bit deeper, it's a combination of a lot of things, but the most important aspect is that people have maybe not recognized the fact or not recognized certain site conditions while they were modeling their site. So give an example, tracker sites, east-west contour on your site. Let's say you're not going to find a perfect flat site, it's never going to happen. So let's say you have a site where there's significant undulation on an east-west direction. You don't have a way to model it on your modeling tools, right? So people generally assume that, okay, it's going to be relatively flat, so let me just model your trackers as a single block and then realize that, oh, okay, it's actually underperforming because there is a east-west shading that they didn't really factor into. So we focus on that at this point. We are trying to work with our developers, work with our owner operators to ensure that they're able to predict more effectively than what it is. Maybe look into the more real life conditions. That's an area of interest at this point. The other area of interest is, rapid shutdown is a very big terminology at this point in the industry in solar, where companies, EPCs and developers are spending a significant amount of money getting more parts for a project, which means more potential causes of failure or more cost to the project. So UL has a new rule that has come in. So my team and I, we are trying to work with the local authorities, the plan checkers, the building inspectors to see if there is a way we can utilize that to kind of avoid the need to put this additional equipment on your roof, thereby reducing the number of failure points as well as reducing the cost. So the ecosystem is depending on engineering expertise to be able to move along to a point where there is way to ensure that safety and compliance is always going to be there, and it's not an afterthought.
You see, that also reminds me, the ecosystem, for instance, solar, need not only be the other parts of the power grid, the other parts of power, such as grid. Today we are also talking about V to G, right? And solar panel to vehicles. So which means we are talking about solar panels which can be connected to electric vehicles in a way where the power can be fed to an electric vehicle battery, which can actually, so the electric car can act as the storage unit, which means the ecosystem components is becoming more and more diverse, and which is where, as you said, following codes, following certain rigorous principles make a lot more difference. That brings me to the best practices. You see, in design in engineering design, there are some best practices which you guys follow. But in your journey so far with Illumine, especially for sizable number of distributed solar for which you guys have done design, are there some specific best practices or systems or concepts that you followed that have made a difference?
Okay. I think the biggest aspect is the codes. You know, the National Electric Code is what dictates how you build any power system, not just solar. But the interesting aspect is that these codes are written just from the perspective of how an electrically system should be engineered. It doesn't specifically talk about how you should build a solar system, right? So some of the codes that have been mentioned might not be relevant to solar, but you still have to end up using those because it's falls under the overall umbrella of electric code. So I think that's where we are at differential at this point, where I think, like, the reason why I said, you know, we're doing engineering for climate tech and not design for climate tech is the fact that, you know, we don't just look at the code and apply it and get done with the project. I think we kind of spend time to look at the intricacies of it, why a certain code says it this way, prepare responses to tell the city or the county plan checkers or the building inspector, say, hey, you know, the code says this, but it is for this particular aspect, whereas we are trying to do something different, so we don't need to follow that particular portion. Thereby, we are ensuring that there is less number of components on the site, so less number of failure points. So I think the focus has always been on safety and compliance, and not necessarily over-engineering or over-designing a particular project.
So what I gather is, when you look at best practices, you are saying you're going beyond what is tangible or prescribed, and you look at certain areas, as you said, over-engineering. And you say, why is this required? Now, a typical engineering guy may not think like that, he just follows the rules. But you're saying you're also questioning a few times and say, maybe this is not required. Maybe the rules for this should be slightly different from what they are for a conventional power grid.
Yeah, maybe just to rephrase what I was saying, I think design is when you look at a certain set of instructions and you put something on paper, which is basically what, you know, like you are referring to, like, you know, there's certain electric codes that are out there, certain building codes out there. You refer those, you put something on paper. That's one way to do it. But to be able to understand why certain code is done in a certain way, does that really make sense in this particular situation? Is what I think a differentiator that engineers should have to be able to keep this industry moving forward, to be to a point where it's tangible with the rest of the legacy industries out there, legacy power industries out there.
So how do you get these skills? So when I look at what you guys do, it looks like there is a lot of electrical engineering, there is civil or architectural engineering. Many of these are conventional skills. You have a lot of electrical engineers, you have CAD engineers, you have structural engineers. Do you bunch them all together in one place, and does that make a climate engineering firm? Or is there something that goes beyond these and that adds the differentiator to a climate engineering firm?
Great question. I think at a primary level, we are more of an electrical and a structural engineering firm. I mean, these are two core components for any of our power or construction engineering projects, right? So there are two different sets of people that we always keep looking at. One is someone who is really good at their core engineering. Let's say if someone goes to school to study electrical engineering, do they really understand the current law? Do they really understand the voltage law? Do they really understand how current flows? So what we look at. Let's say if it's a mechanical engineer who is, or a structure or a civil engineer, the first thing you look at is, does this person understand how loads affect a particular structure? How do you figure out what is the particular force needed to maybe break something? So these are basic level of intuition that we look at our candidates, and if that is there, then getting them on board, because none of the colleges unfortunately have a curriculum which teaches you solar. There might be a specific course which talks about renewable sources of energy, where they'll say solar, gets energy from sunlight, gives you electricity, but nothing more than that. So maybe, that's just the reality. Where the curriculum is right now. So it's not really. There's no way that you can find. We might find energy engineers, people who done a certain university that offers energy engineering as a course. That solar is a much bigger part of
So
the
how do you guys get the solar component into this guy's head?
It's basically getting them into our curriculum. We have built about a 3-month, 12-week-long program right now to have engineering graduates out of college to be able to understand what solar is, get to the basics of it. It's more of a traditional classroom and more of a practical, on the job kind of a training program that we have built to, which we have tailored over the past 3 years. We have made a curriculum. We saw what worked, what didn't work, so we course corrected it. So every time we hire a batch of folks, we have kind of kept on improving the system, improving the curriculum. Now we are at a point where we're comfortable to say people spend 3 months in the program, and then when they come out, they are ready to take up these engineering jobs for our projects.
So essentially, the formula seems to be get guys who are very good in fundamentals, be it in electrical, be it civil, or mechanical, but add that solar component to it through your customized training.
That's kind of worked out well, because I think the principle of it is still your core electrical engineering. Even if it's solar, you're still talking about how you are going to electrically transmit those the current into to a point, from a point A to a point B, right? Yep. So it does help. I think someone who's fundamentally good at understanding their engineering substance, electrical or structural or mechanical, as long as that understanding is there, the 3 months is going to be really good time to kind of get into the solar side of things.
To me, it looks like you're being very humble when you talk about this 3 months, because 3 months is a long time for training, right? And the fact that you guys invest those resources into those 3 months of training, I have a feeling that it makes a tremendous difference to that guy. As I said, you are probably being very modest when you talk about the 3 months training as a 3-month training. But I think, and as you said, this training has evolved over a period of time. You guys have looked at, this components of training work, but I have to improvise this. And over a period of time, there's a good chance that you guys have put together a very, very effective training program that makes a very good electrical engineer a very good solar electrical engineer.
Exactly. No, I think it speaks for itself. I think we have had folks who have wanted to venture into EPC side or commissioning side and everything. So they have all spent a couple of years here, gone on to work for EPCs that we know in India, and having a good time, or being able to apply what they've learned more interestingly to their particular subset of what the companies are doing. So yes, I think we are seeing those results in terms of people not just understanding how to design engineer a project, but also on top of that going and adding value in different places.
So with all these with you, an excellent team, a very good team to work around, and now 7-8 years experience in this field, very successful at it. What are you guys currently working on? What are the major climate engineering themes you guys are working on, and any brief thoughts on where you guys want to go in future?
Sure. I think right now our biggest focus has been on energy storage, that is battery energy storage systems. I think I think probably in the next 3-4 years you'll probably see every solar project including having an energy component in it. So our focus is right now on building those technical capabilities to be able to handle more energy storage, be it sizing the batteries or figuring out different battery chemistries that will make sense for our clients. So our major focus right now on the power side is on energy storage at this point. We are working on a couple of other things on the construction side in terms of branching out more scope offerings. Like you mentioned, we do right now green buildings, wind modeling, and etc. So there are a couple of areas that we've understood is a good adjacency for us to get into. So we are putting time and effort on those to be able to kind of start expanding the scope of work that we take from each of our clients, being an architect or a developer for the construction side.
But the core work you do, the residential solar, distributed solar, what are the key offerings you have right now with that?
Okay, our major USP is design and engineering. I see these are two different components because there are a lot of companies out there who does only design. There are a lot of companies out there who does only engineering in the solar space, be it residential or DG or utility scale. You will see companies which does either of those two, and it's hard to find someone who does both. So I think the last 2 years we have really focused on being able to offer both these umbrellas of system engineering in a single place. So that's how we are right now, and that's kind of how we are going to continue for the next 1-2 years in terms of being able to offer both design and engineering for our clients. Engineering includes the ability to be able to stamp or seal our own projects, like how you have motor engineers or you have these licensed engineers, so where someone has to look at the drawings and say, hey, this looks fine, I'm going to put my seal on it. So that capability we have got in-house now. So there are companies who do design, there are companies who does only engineering, that is the sealing part, but we are at a point where we are able to do both at this point in-house. So that's the differentiator that we have in the industry right now.
And the three key verticals you operate in, solar, wind buildings, storage.
So we don't have solar separately. We call it power engineering.
Okay.
So solar, EV charging stations, energy storage falls into our power engineering business unit. Then we have construction engineering. Construction engineering is where we do all the wind buildings, BIM modeling, digitizations, MEP drawings, and everything. And then we have another subset which is called license engineering. That group is the one which is the engineering arm of the company, where we provide all the stamping and sealing of all our projects.
Hey, thank you very much and all the very best.
Thank you. It was a good meeting you today. Thank you.